morning, good afternoon, welcome, dear SAMAT followers. Today we are going to see one small customization performed by SAMAT over Liftdesigner software in order to get quickly and fast shaft structures to be installed in elevators, mainly for modernization, test towers, and so on. As said before, that's a small parameterization, customization, a small software inserted in Liftdesigner. We are not going to talk about Liftdesigner because this is a software well known in the elevator industry. But this is an add-on that will help to the application engineers and the modelers to increase efficiency on the design of the shaft structures. Starting point for this software is to create an elevator in Liftdesigner with all the floors and so on. Here we have a sample, one elevator, 5 stops, 2 access sites, but this is inserted in a conventional standard shaft. We can see here the 3D. This is just a standard shaft, and we have accesses in one side in the main entrance and in the other side in the rear entrance. The customization performed in Liftdesigner is to replace the existing shaft with a metallic structure. Let's see the process. Once the elevator is already designed, we are going to upload an Excel template for the data entry of the metallic shaft structure by using the Excel templating. The first step, load the template and accept the changes. In this process, if you have seen here, the software has deleted the existing shaft, and now we are going to replace the existing shaft by a metallic structure shaft. This is a standard model, 630 kilos, 8 person, typical residential market. For this application, we have selected a rucksack elevator, but it can be used with a normal standard elevator, basically with all kinds of elevator models. So, first step. We enter data for the main structure, for the pillars and the headroom. Basically, here in this drawing, we can define the dimension of the different profiles that will produce the structure. Here we can select 150. The height of the profile we can put 200. It depends on the facilities available. And later on we will go to the finishing of the different materials. Now, if we accept the changes, now you can see that the structure has been built in the 3D model. But it's not enough because we have to place the transversal beams in order to fix the doors, to fix the rail brackets, and so on and so on. These are the next steps. Also, you can select the finishes. In that, here I have selected a white coated, but if you want a metallic thing or metallic iron, you can change the color or the appearance of the test tower. Let's go ahead with the lateral size of the structure. Similar to the previous process, we define the thickness of the profiles and the dimensions of the profiles. In that case, normally these transoms shall be a little bit smaller than the main pillars of the structure, but we can put any dimension we have available in our facilities. We accept the changes. Have you seen that all the transversal pillars for fixations has been created into the structure. These are for the lateral side. The next step is for the entrances, for the front landings and for the rear landings. Here we have all these landings, but all these doors are floating and we have to fix them into the structure. So for the front landings, similar to the previous process, we define the profiles. And the different profiles where needed has been appeared into the structure. So the software decides if there is an access, if there is not an access, then if this is a reinforcement profile or not, and place it accordingly into the shaft structure. For the front landings and for the rear landings, similar. Basically now the structure is already finished. And we have enough information now to pass to our dealers for a local manufacturing. The last step in the process is if we want to declare walls into the shaft structure, enclosures, we can define side per side. If we go up into our template, for instance, in the top, we can define if we want enclosure, yes or not. If we say yes, we can define for instance, metallic mesh structure, and we need to declare the thickness. And here you can see how the enclosure of the top. We go now to the sides. The process is similar. In the side, we define if we want enclosure or not. In that case, we are going to have on the left and on the right. We select one finishing and one thickness. And now the entire shaft structure has been covered by the desired enclosure. It's independent, the definition of the enclosure in the lateral walls that in the front and the rear side. Because normally for modernizations, one part of the metallic structure is adjacent to the existing building, and maybe it's finishing later on with masonry. And then the structure is empty. And it's quite common as well in the other side of the structure, for instance the main entrance. We can create an enclosure made by crystal, and these options are possible to select here. Front landings, we can select enclosure, yes. With glass, all this wall shall be made by glass, and we define the thickness of the glass could be 10 millimeters. Picture maybe you cannot realize quite well because it's a glass. And the final part shall be to define the enclosure for the rear part, where we have all the accesses. In this part that normally we can get it empty, or we can define an enclosure as well. Now the modelization is finished. As of here, what we can obtain are the drawings of the different parts of the metallic structure, the pillars, of the enclosures, of the different finishings and so on, and provide it to your local dealer for manufacturing. Thank you very much.